Now we are going to study what is time temperature transformation diagram. Will be asked in the examination. What is TTT diagram? What is the process of plotting the TTT diagram? Or only draw the self-eccentric stages of the following. Draw the TTT diagram and show all the phases, nomenclature, etc. Why it is called as IT diagram. All the things I am going to explain you today. So today's lecture is again important because this diagram shows how different phases are produced. Now, how to define? Before we study the plot procedure for plotting of the diagram. So, what exactly meaning is of TTT diagram? TTT diagram provides lot of information about nature, start, and finish of transformation rate and transformation phases with hardness. I repeat once again. The TTT diagram provides lot of information about what? Nature, start and finish of transformation, rate of transformation, and the transformed phases present with the hardness. So I want to explain here. If this diagram shows perlite, bainite as well as martensite produced from austenite phase. So long form of TTT diagram is time temperature transformation. TTT. You can write this full form also in bracket. Whatever title you have written, I have shown it on the blackboard, whiteboard. Below it, you write time temperature transformation diagram. Every T you just make capital. TTT. And next line, it is IT. Long form is isothermal transformation diagram. IT diagram. Now you have studied thermodynamics. You know what is isothermal transformation. So when any of the activity takes place at constant temperature, then it is called as isothermal transformation. So here, transformation of austenite into perlite or transformation of austenite into bainite or transformation of austenite into martensite takes place at constant temperature. In day-to-day life, whatever processes are going on, that is not at constant temperature. That is continuous transformation. But before we go to continuous transformation, we must know what is isothermal transformation. And once you will come to know what is isothermal transformation, then automatically you can understand how castings are cooled continuously in the air. Okay. So now first write the definition, then I will start explaining. During my explanation, don't write anything. Initially you write the definition of TTT diagram. Right? TTT diagram provides lot of information about nature of phases. Nature means nature of phases, comma, start and finish of transformation. Start and finish of transformation, comma, rate of transformation, and transformed phases. Means which are the phases? Transformed phases are perlite, bainite, martensite. Transformed phases with its hardness. Full stop. So this time temperature transformation diagram gives this lot of information about or whatever parameters have dictated to you now. Next line, as transformation takes place at constant temperature, as transformation takes place at constant temperature, comma, it is also called as isothermal transformation. I capital T capital. Isothermal transformation. Next line. Procedure for plotting TTT diagram. Now pay attention. Now this TTT diagram is plotted by thermal experiments where number of samples are heated to the predetermined temperature. They are soaked in that range so as to get homogeneous austenite. Yesterday I explained to you what is meaning of homogeneous austenite. So the samples are heated in the austenitic zone. Austenitic zone means the area or the temperature range at which the phase is complete austenite. How to calculate particular temperature at which phase is 100% austenite? That is from iron carbide diagram. So just turn the pages back and see your diagram. So I have shown yesterday. If steel is 0.8% carbon, draw the vertical straight line. Automatically above 727, it shows 100% austenite. But if you take less than 0.8% carbon, that is for example 0.4. So at 0.4% carbon, draw vertical straight line. Where it cuts the A3 curve, above that there is a 100% austenite. So for every steel, A3 temperature is different. Okay, because A3 is range. So depends upon type of your steel, you have to select the heating temperature. That's why the word is predetermined temperature. Now let us take eutectoid steel, because eutectoid steel gives 100% per line and easy for study. So now procedure for plotting the TTT diagram for eutectoid steel. You can write in after that procedure for plotting TTT diagram in bracket for eutectoid steel. Why eutectoid steel? Because only one phase is there and we can easily convert austenite into perlite. So instead of having mixture of alpha and P, it is difficult to understand. Okay. Now how experimentation is carried out? It consists of selecting around 25-30 samples, or maybe more than that. Whatever number of samples you have to take and heat them at higher temperature. Now austenitic range for eutectoid steel theoretically 727, but practically I told to get homogeneous austenite you have to go at little higher temperature as per the whatever these terminologies are decided by the technocrats. You should always heat 30 to 40 degree more. Means if your heating temperature is 730, you have to heat at 770. So that by 30 to 40 degree more heating, you can ensure the homogeneity of austenite and soak there. So this is the temperature part. Don't do anything. I will give time to draw. Temperature bath. Why I am saying bath? Actually, there are different types of furnaces. One of them is bath furnace, where the high temperature salts are boiling, and in that liquid bath furnace means heating made is liquid. So in that, now you may ask how liquid is used for heating. Potassium cyanide, sodium cyanide. So these temperature paths are having melting point more than 500 degrees Celsius. Why heating media is liquid? Because it heats uniformly. It touches the sample from every corner. So in that temperature bar, whose temperature is in the austenitic zone. So I will write suppose 800 degrees Celsius. We have taken 0.8% carbon steel. So at 800 degrees Celsius, it shows 100% austenite. All samples are having austenite now. You have kept it at constant temperature. Now, to follow the experiment, so you have to take one sample at a time. Because I am supposed doing experiment at temperature 650 degrees Celsius. So here is a liquid 650 degrees Celsius. It is T1, capital T1. Now imagine, below 727, there is no austenite. So now I will draw the microstructure here. All is gamma. I have taken one sample. I know that here is 100% austenite. Now I will take this sample. I will dip at 650 degrees Celsius. So temperature drop 800 to 650, and you are below 727. Means there is no stability of austenite. So below 727, there is a perlite. Okay, but now how that perlite is produced? That mechanism I am explaining. Okay, so step number 1, I will first hold it for few seconds. Suppose I hold for 5 seconds. I have taken this sample, put in 650 degrees Celsius bar, hold there for 5 seconds, and then immediately taken out and quenched. After quenching, %, martensite, 0% perlite. What is logic? I repeat once again. Samples which are having 100% austenite, I have taken it, cooled. Now I am saying cooled because temperature drop 850 to 650. I have cooled it at 650 degrees Celsius. But I have not given any time, or I will not wait there more than 5 seconds. I will put there, and after 5 seconds, I will take it out and quench in water. Meaning of quenching means water putting. So I will quench it. I got 100% martensite. The meaning is that in these 5 seconds, perlite has not yet started to form. When perlite will form, this is FCC structure, and perlite is mixture of BCC plus orthorhombic. So to convert FCC into BCC plus orthorhombic, movement of atom is required. Atoms will move here and there, they will rearrange themselves, and for rearranging themselves, some time is required. I have not given that time. That's why there is no use of dipping the sample in 650. म्हणजे इथं याच्यामध्ये ठेवण्याचा काहीच अर्थ नाही. डायरेक्ट सॅम्पल इथून पाण्यात घातल्यासारखं झालं ते. There is no use of holding at 650 because no transformation started. Okay, I will carry out same experiment for another sample. I will keep this sample aside. I will take one more sample from it and dip here. Now here I wait. Now this experiment is over. First experiment is over. Now second sample, second experiment. I have hold because both are same structures. All are having austenite. I have taken it and hold in this bar for 8 seconds. See what happened. Here, atoms will start moving. More than 5 seconds, we wait. Remember, 5 seconds, 8 seconds, these are just for example. In actual, time may be different. I have, for your understanding, I have taken this just as an example, these types. It is observed that after 8 seconds, some movement of atom takes place and some FCC is converted into mixture of BCC plus orthorhombic. पण हे सुरू झालंय जस्ट, पण मी त्याला वेळच दिला नाही. हे उचललं पण सॅम्पल घ्यायचं आणि पाण्यात टाकून दिलं. Now what is this? 95% martensite and 5% perlite. I hope you understood now. In 8 seconds, some transformation has started, but I have not given time for ending that transformation. थोडा वेळ ठेवलं आणि लगेच बाहेर काढलं आणि लगेच पाण्यात टाकलं. पण हे जे 5% इथं झाले तयार, त्याच्यामध्ये काही चेंज होत नाही. ते 5% तयार झालेलं आहे असं राहतं परलाईट. पण 95% जे ऑस्टेनाइट आहे ते फास्ट क्वेंचिंग केल्यामुळे, पाण्यामध्ये कूल केल्यामुळे त्याचा मार्टेनसाइट झाला. नाउ दिस एक्सपेरिमेंट इज ऑल्सो ओव्हर. I will take one more sample and third experiment. Now in this case, I wait for 12 seconds. For third experiment, I wait for 12 seconds. Here you observe that some transformation has progressed. Same sample I will quench, and now I got almost 40% perlite. Here 60% martensite and 40% perlite. What is meaning? In these 12 seconds, Around 40% perlite starts here, form, but you have not given time for completion. Immediately you have taken it and dipped into water. मग जो 7% ऑस्टेनाइट राहिलाय त्याला तुम्ही इतक्या फास्ट कूल केलं की त्या एफसीसीचं बीसीटी झालं. त्याला बीसीसी प्लस ऑर्थोरोम्बिक व्हायला वेळच नाही मिळाला. आय रिपीट वन्स अगेन, रिमेनिंग 60% ऑस्टेनाइट you have not given time for movement of the atoms and directly you have taken and dipped into water, so that will form martensite. Now this experiment is also over. Fourth experiment. Now at this time I will wait for more time. I will wait now this time. $16. Quench. 10% martensite, 90% perlite. What happened? Same type of material, I have taken it and hold in the bath of 650 degrees Celsius, where after 16 seconds there is a sufficient time, so atoms of FCC structure will move now because they are not stable below 727. As soon as they come below 727, FCC structure disturbs and atom will start moving, and they will move and rearrange themselves into mixture of BCC plus orthorhombic, and almost 90% structure is produced in 16 seconds. But still I didn't give time for completion. Immediately I have taken it and dipped into water. The 10% FCC, whatever remained, it is quenched very fastly and it converts into BCT, that is martensite. But remaining mixture of BCC plus orthorhombic, that is perlite, remains as it is. Experiment is over. Last experiment. Now here I wait for 20 seconds. I wait for 20 seconds. %100% perlite. Now my question to you. I came to know with this experiment that once I will take the sample from the austenitic zone and I will hold it below 727, for example 650. If I hold around up to 20 seconds, and now same sample I will take and I will quench in water at 20 degrees Celsius. It will not make any effect. 100% perlite is already formed here itself in this bath only. And thereafter, if you take it out and quench in water, perlite remains perlite. It will not convert into austenite, into martensite. Yesterday only I told, if you want to form the product, it must be from the parent phase. So austenite can be converted into martensite. Austenite can be converted into benite. Austenite can be converted into perlite. But perlite can be converted into martensite. Okay. So here 100% perlite is already formed. And if you quench in the water, it will not make any effect. Now my question. I have suppose these 50 samples. Only 5 experiments I have carried out. Remaining 45 samples are still having austenite. If I will take all 45 samples and I will put at 650 degrees Celsius bath and I will wait for more than 20 seconds, what will be the microstructure for all 45 samples? Hello? Somebody answer. Are you not getting my point? Hello? Are you not getting my point?
Sir,
My
please
question
repeat.
is that, my question is that, if I will take all 45 samples, I will dip at 650 degrees Celsius. Hello? And I will wait here for more than 20 seconds. What will be the microstructure of all 45 samples? If you take the samples from this bath and quench in water after 20 seconds in this bath. Hello? Who is answering?
Last, sir.
I'm not getting anything.
Sir, BCC plus orthorhombic.
That is called as?
Perlite.
Correct. Absolutely correct. So, what I came to know from this experiment? I came to know from this experiment that transformation starts at 8 seconds and it finishes at 20 seconds. Before 8 seconds, no transformation has started. Means even your austenite is present above 727, you can hold the austenite below 727 also up to certain seconds. म्हणजे 7 सेकंदापर्यंत तुम्ही ऑस्टेनाइटला ऑस्टेनाइट ठेवू शकता लो टेम्परेचरला सुद्धा आणि त्याच्यानंतर मात्र ठेवू शकत नाही कारण लगेच मूवमेंट सुरू होते and transformation starts at 8 seconds and if you hold for little time it will go on continuing and it will finish at around 20 seconds. So transformation starts at 8 seconds and finishes at 20 seconds. All samples dip in this bar for 25 seconds and if you remove it and Hello, am I audible? If you remove it and quench in water, all samples will get perlite structure. Perlite is mixture of ferrite and cementite. That is BCC plus orthorhombic. So from this experiment, we came to know that some time is required for start of transformation. So what is that time? It is called as incubation period. So before I dictate this concept to you, you have to draw this figure. Use your maybe horizontal side of the notebook. All figures should be drawn in well manner. I will wait for 2-3 minutes. Start drawing it. Over. अजून वेळ आहे
Yes,
का?
sir.
Is it over?
No, sir, wait.
Okay. Roll number 23 and roll number 16. Hello.
Yes, sir.
You change your style of writing, not 60, roll number 60 and roll number 23.
Yes, sir. Yes, sir.
You have not written correct roll number. You have written TY underscore B underscore C. Don't write that way. You have to write TYB underscore 60. And roll number 23, you also write TYB underscore 23. So
Yes,
next
sir.
lecture you remember, so that we can have sequence properly in the chat box, this attendance box.
Over, sir, over.
So I repeat, the transformation does not started initially in first 7 seconds. If I repeat the experiment for 5 seconds, 6 seconds, 7 seconds, I always get 100% Martenside because transformation does not started. So the initially started if is called as incubation period. So write down the definition. Go to next page and write down. I am going to erase this figure now. Incubation period, the time during which transformation does not proceed is known as incubation period. So rate of transformation versus time. Draw this diagram along with me. We have less time, so you can draw the diagram with me. So what I have written here, I will tell if it is not visible. 0, 50, 100. 0, 10, 20, 30, 20. In that way you can write up to 100. And name to the axis, that y-axis is rate of transformation. Here is a time. Now pay attention. Initially, when you hold your sample at 650 degrees Celsius, suppose for 0 seconds, transformation does not start. 1 second, no start. 2 seconds, no. 5, no. It starts at 8 seconds. Once again I repeat, these 5 seconds, 8 seconds, 20 seconds. This time, I have taken just for your understanding. Okay, you can write any time accordingly. So at 8 seconds, transformation starts, and transformation will proceed. So at 9 seconds, 10% per line. At 12 seconds, 40% per line. At again 13 seconds, 50% per line. At 16 seconds, 80% per line. At 20 seconds, 100% per line. So here is 0% per line, and here is 100% per line. So this plot will be in this way. Here is 8, and here is 20 seconds. Okay, transformation starts at 8 seconds, 0% per line, and it finishes at 20 seconds with 100% per line. Now, whatever definition you have written is here. This is called as, draw this, small t, and write incubation period. Incubation period. The time, initial time during which transformation does not proceed. Why? Because smaller the incubation period, transformation will start faster. So if incubation period is 2 seconds, your transformation starts immediately within 2 seconds. If incubation period is larger, transformation will start late and finish late. So very simple statement. Smaller the incubation period, faster the transformation. Higher the incubation period, slower the transformation. Now this one experiment concluded with one graph. So in one experiment, we have carried out I repeat once again. That is T1 is equal to constant. That is 650 degrees Celsius. Why it is called as IP diagram? This is the example. So at constant temperature, transformation starts and transformation finishes. So this is one experiment in which 5 sub-experiments I have carried out to measure the percentage of transformation at different time. Now same experiment for lower temperatures. Same experiment. May I erase this figure?
Yes.
Yes, sir.
One more such figure we have to draw. Minutes I will take. In 5 minutes I will finish. Now experiment I have repeated for T2 temperature 600 degrees Celsius. This is for T1 temperature. This plot we have already drawn for T1 temperature. And this is incubation period for T1 temperature. That's why I write small T1. You also draw in the same way. This is small T1 and this is T1. Now, if I take cooling temperature 600 degrees Celsius, then same plot I will get. Whatever experiments are repeated for 650, same experiments are repeated for 600 also. And in that case, I got that incubation period decreases. So second plot I am plotting here. This is for T2. And this is small T2. What is the meaning of this? As cooling temperature decreases, incubation period decreases, rate of transformation increases. I repeat once again. As temperature of cooling decreases, so earlier it was 650, I make it 600. What will happen? Incubation period earlier it was 8 seconds. It becomes now 5 seconds. In this way, as temperature of cooling decreases, incubation period decreases, rate of transformation increases. Same experiment I will carry out for 500 degrees Celsius. T3. And I got this curve. T3. Same statement I repeat. As the temperature of cooling decreases, incubation period decreases. Now it becomes 2 seconds. As lesser the incubation period, initial transformation starts fastly and finishes fastly. So lesser the cooling temperature, smaller will be the incubation period, faster will be the transformation. But friends, this is not true every time. As you go on take cooling lower and lower temperature, this formula will not work. Now it becomes a reverse formula. Now I have taken experiment number 4. Temperature 400 degrees Celsius bar. Same 5 sub experiments I will carry out. And now see the curve. T4 and small t4. Now my statement is, I will modify it. as the temperature of cooling decreases, incubation period decreases, rate of transformation increases, but if temperature is very less, at that time reverse effect takes place and incubation period increases and rate of transformation will be slow. That's why for T4 temperature, this incubation period is more and rate of transformation is slow. Same experiment if I carry out for 300 degrees Celsius, I got T5 and this is T5. Up to this you draw. Why this is happening, that I am going to explain you in the next lecture. Only remember, I am going to repeat the statement. As temperature of cooling decreases, incubation period decreases, rate of transformation increases. But at lower temperature, reverse effect takes place and incubation period increases and rate of transformation becomes slower. And why it is happening, that reason I am going to explain you in the next lecture. So in 1 minute you draw figure and then I already taken screenshot of your attendance. Once your figure is over, you can exit the meeting and join the next class. Don't take the break now, immediately join the next class. Okay? Thank you very much.